Okay, so we're gonna jump into some trig equations here. We got square root of 2 sine x equals 1. So like any equation where x only appears in one place, we can just use basic inverse operations to isolate x. So what are the inverse operations? Well, we've got multiplication here, square root of 2 times sine x. Sine x is, sometimes people get confused, like sine, log x, like those are multiplying x. Those aren't multiplying, they're acting on x. So sine x is really a unit. And to get into what x is, we're going to have to use the inverse sign. But the first step is to get rid of the square root of 2. So we'll divide both sides by the square root of 2. So then sine x equals 1 over the square root of 2. And at this point, it might be helpful to see this as the square root of 2 over 2. You may not recognize it like that. That's the rationalized form. This should pop off some memories in terms of the unit circle. Of course, we could just use a calculator to answer this question, and it would provide us with an answer. Let's take a look. I'm in degree mode, so inverse sine of 1 divided by the square root 2. So it turns out that answer is 45 degrees. From the calculator's perspective, x equals 45. That's in degree mode. Now, the problem is that this is not the only solution. And this has to do, again, with inverse functions and the fact that putting in a single input will only give me a single output. But my knowledge of the unit circle tells me that where sine x equals the square root of 2 over 2 is in two places. One is here, the one that the calculator told us about, and the other one is over here. And this one is 135 degrees, or pi fourths and 3 pi fourths, if we're talking in terms of radians, which we probably should be, as we're thinking about solving equations. It's very traditional to do that in terms of radians, which is messy here from a, when you generate the inverse sign in radians, it doesn't give you pi fourths unless you got a super fancy calculator. It's going to give you whatever the decimal approximation of pi fourths is. So one point is that anytime you get down to, a statement like, I want to know cosine x equals 0.8, there are two solutions to that. There's going to be one solution that the calculator provides, the other solution we have to work out. So what you need to know is that for sine, if my first solution, theta 1, is 45 degrees, then the other answer is 180 minus theta 1. That's theta 2. So if sine theta 1 equals whatever, a, then theta 1 equals the inverse sine of a, and theta 2 can be generated by doing 180 minus theta 1. And that's because this angle, there's symmetry, right, between this and this in terms of the sine values. So if this is 45, this is 45, I can get this 135 by doing 180 minus that. Now, for cosine, it's different. Cosine of this angle equals b, then I can use my calculator to figure that out. But then what I do to find the other solution would be to just, let me put the negative on the other side. Say that negative theta 1 would equal theta 2. Okay, so those are two different ways of getting the second solution. Now, the second solution may or may not be necessary. Maybe they only want one solution. Maybe they want two solutions. Maybe they want an infinite number of solutions. Because keep in mind that if we think about this from a functional standpoint, let's go over to Desmos real quick. So let's say we're looking at y equals sine x, and we want to know where that equals 1 over the square root of 2. So there's a lot of solutions to that. I'm just going to circle a bunch. 1, 2, 3, 4, 5, 6, 7, 8. Within every 2 pi, there are two solutions to this. And this cycles around and around and around. So there's really an infinite number of solutions. So my finding two solutions is just the starting point, because then I can just add on a period to get to the next solution. And as long as there's no factor inside, which is making my period different, I can just add 2 pi. So the finish line of this problem, if I'm getting all solutions, is this. Let me get rid of that, because we're going to do this in terms of radians, like I said. So x1 would be pi fourths, x2 would be 3 pi fourths, and to make it all solutions, I add on 2 pi n, and n needs to be spelled out, is any integer. So what the heck is going on with this 2 pi n? Well, basically, I know that every 2 pi step away from whatever angle works will be another angle that works, because it's going around in a full circle. So I think about the unit circle. If I'm here and I go around 2 pi, I'm back to the same point. So that's another solution. So by making it 2 pi n, where n is any integer, I'm talking about 2 pi, I'm talking about negative 2 pi, I'm talking about 4 pi, I'm talking about 6 pi and negative 8 pi. So because n is integers are, you know, dot, 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 negative 2, negative 1, 0, 1, 2, 3. It's just a nice succinct way to cover all of my bases in terms of all of the solutions. Okay, let's look at another one. 4 cosine x minus 2 equals 3 cosine x minus 2. Okay, you're welcome to take a stab at this one. Press pause, come back, add 2 to both sides. So 4 cosine x equals 3 cosine x. Now I'm actually going to combine like terms. So I'm going to subtract 3 cosine x from both sides. So this is cosine x, 1 cosine x, which is cosine x, is nothing, 0. Okay, so now I got to find out, when does cosine x equal 0? So I actually like to think about this in terms of this functionality. It's going to happen here and here. And so from the unit circle perspective, we're talking about x equals pi halves and x equals 3 pi halves. I could also use my trick and say my second solution is the negative of the first solution, negative pi halves, because that is another answer. And now, again, with no coefficient here, I know that the period is 2 pi. So I'm just going to add on 2 pi n, 2 pi n. Okay. Now, if you have a problem where it boils down to something like this, there should be some rounding instructions, like round to the nearest 4 decimal places or something like that. So then I use my inverse in radian mode. I got, oops, I'm in degree mode. That's way too big of an answer. .4510. That's answer 1. Answer 2, negative 0.4510, plus or minus. Don't need plus or minus since I made these integers, 2 pi n, and I've covered all my bases. Okay. And if you're curious, you know, pick an n value, n equals 3. So 0.4510 plus 6 pi. Put it in my calculator. I'm going to add 6 pi to this. And I'm going to stick that into cosine. And I get back to 0.9 exactly, because I didn't do any rounding on my calculator. What happens if this is not just sine x, it's sine 2x. So first of all, the algebra is the same to start. We're going to subtract root x, root 6. So square root of 8 sine 2x equals negative root 6. Divide by the square root of 8. Divide by the square root of 8. Sine 2x equals, I got to simplify this a little bit here. This is 2 root 2, and that means that this is negative square root of 3 over 2. So that was a very clever disguise of one of our unit circle values. All right, so where does sine equal negative root 3 over 2? It happens here and it happens here. So that's 4 pi thirds and 5 pi thirds. 2x equals 4 pi thirds and 2x equals 5 pi thirds. Before I divide by 2, I should add on my 2 pi n, because then when I divide by 2, I'll do the proper adjustment of the period not being 2 pi in this case, right? Because we know when there's a value, b value of 2 here, that actually is a horizontal shrink, which means that the 2 pi period is cut down to pi. So my last step here is a little complicated algebraically. I'm going to divide by 2, but I need to divide by 2 across the whole expression. So this would be 2 pi thirds plus pi n, that's x1, and x2 is going to be 5 pi 6 plus pi n. Those are the two solutions that make this, well, these are the infinite number of solutions that make this true. 2 pi thirds and 5 pi 6 are the two solutions that make it true based on the first circle. And actually, because it's been divided by 2, it's actually within the first 180 degrees, the first pi radians. So that's a little bit trickier of a problem. So lots to think about there. If you're forced, I guess the last thing I would say is, if the problem provides, let's just do 4 sine x plus 6 equals 8. If the problem provides that x needs to be in a certain range, then that just means that you have to think about only the solutions that appear in that range. I've given a pretty small range here, so it should make our lives a little easier. This is going to be 2, so sine x equals a half. Where does sine x equal a half? We're talking about x equals pi 6 or x equals 5 pi 6. And again, where did that come from? It came from my knowledge of the unit circle, thinking about where the y value of an angle was equal to a half. That's this point, and it's this point over here. And that's the pi 6 and the matching 5 pi 6. If I just get one, I can get the other one by doing pi minus pi 6. I don't have to remember what the other value is. Okay, that's a lot to take in. Watch it, rewatch it, ask me questions. This is a big deal.